So tonight we're talking all about multivariable equations, and a lot of times you might also hear them called literal equations. Literal equations. All right. So we're going to solve two different equations shown for x. So let's say we start with this one. 2x minus 5 is equal to 13. So if we're solving for x, this is a two-step equation. We would add 5, cancel out. 2x is equal to 18, and then we divide by 2. And we do all that because we're using inverse operations. So if we see that x is being multiplied by 2, we know we're eventually going to divide by 2. If we see that x is subtracted by 5, we're going to do the opposite, which is add 5. So we do that. The same principle follows when we have a multivariable or a literal equation. So let's say for this one we're solving for x. So looking at x, I can see that it's being multiplied by a and then subtracted by b. Just like in our algebraic equation, we're going to follow the same steps in inverse order of operations. So instead of GEMDAs, or grouping symbols, exponents, multiply, divide, add, subtract, we're going to go in inverse order. So we're going to start looking for addition, subtraction, then exponents, then multiply, divide. That's not right. We're going to look for addition, subtraction, then multiply, divide, then exponents, then grouping symbols, okay? So addition, subtraction comes first, and we can add b to both sides of this equation. That becomes a zero pair. We're looking at ax is equal to c plus b. Now, in our algebraic equation, we were able to combine 13 and 5 and make it 18. That's because 13 and 5 are both numbers. They're like terms. Are c and b like terms? No, they're two different variables. So we can't combine them. They stay as separate terms, c plus b. Okay, so now we have a times x. We want to get x by itself. So we have to do the inverse of times a, which is divide by a. Divide by a. Those cancel. X is equal to c plus b over a. And so that is how we would solve a literal equation. So just like in a normal algebraic equation with numbers and one variable, we are using inverse operations and we're doing the opposite order of operations. All right. So let's do some examples. So let's start off with some one-step problems. So for number 1 here, and I'm going to rewrite these, we have a is equal to length times width, or L times W. This is a area equation we should recognize. And we're going to solve for W. So I like to put a little arrow above that. I'm solving for W. Well, W is currently being multiplied by L. So we need to do the inverse of that. Inverse of multiply by L is divide by L. So we're going to do that. Divide by L on both sides. And we're left with A over L is equal to W. And that's our answer for number 1. So notice how we started with 1, 2, 3 different terms. How many terms did we end with? Well, we ended with 1, 2, 3 different terms. So when you have multivariable or literal equations, you're not really getting rid of the variables, you're just moving them around according to algebraic operations. All right, so we have A is equal to B times H, and we're solving for H, So looking at H, I see that it's being multiplied by B, so we have to do the inverse, which is divide by B. So on both sides of the equation, we'll divide by B, and we have A over B is equal to H. And I leave A over B just like that, A over B, because A and B are not like terms, so we cannot simplify them any further. Here we have D is equal to R times T. We're solving for T. T is being multiplied by R, so we're going to do the inverse, which is divide by R. Do that to both sides. T is equal to, D cannot be simplified by R, so D divided by R is equal to T. All right, I'm going to give myself some room for this next one. So we have I equals PRT, and we're solving for t. So I equals PRT, we're solving for t. So looking at t, it's being multiplied by both p and r. So if it's being multiplied by two terms, we can actually divide by both of those terms at the same time. So for this equation, we can divide by PR, divide by PR, and we're left with t is equal to I over PR. And that's it. All right, for this next one, V is L times W times H, and we're solving for H. This is similar to the previous one. H is being multiplied by LW, so we're going to do the opposite. We're going to divide by LW. And we can divide by both L and W at the same time. So divide by LW, divide by LW. H is equal to V divided by LW. All right, number 6, C is equal to 2 pi r. We're solving for r. So this one actually does have a number. It's got that 2. And then looking at r, it's being multiplied by 2, and it's being multiplied by pi. So we're going to do the inverse. We're going to divide by 2 pi, divide by 2 pi, and we just have C over 2 pi is equal to r. All right. So that was a lot of multiplying and dividing. Let's get some other stuff in here. So we have m is equal to c minus s, and we're solving for c. So there's c, and c is currently being subtracted by s. So the inverse of subtract by s is add s. So we're going to do that to both sides. Now m and s cannot be combined because they're different terms. So our new equation will just look like this. M plus s is equal to c. So again, we don't really lose any of our variables, they just shuffle around. We're going to solve this one for pi. So if I have a is equal to pi times r squared, so the squared is connected to the r, so the squared is not actually squaring pi. When we look at pi, all that's happening to pi is it's being multiplied by r squared. So we'll do the inverse, which is divide by r squared. Divide by r squared, divide by r squared. And our final answer is a over r squared is equal to pi. All right, for this last one, D is equal to m over v. So there's our density formula. Recognize that from science. We're going to solve for m. Well, m is currently being divided by v. So what's the inverse of divide? Multiply. So let's multiply this side by v, multiply this side by v, and we have dv, so d times v, is equal to, those cancel, m. Okay. So let's see what happens when we have multi-step problems. So again, when you have multi-step literal equations, you want to use reverse order of operations. So reverse GEMDAS. All right. And we're going to get rid of fractions. By multiplying by the reciprocal. So reciprocal is like the opposite. So if you have 1/4 times something, you're going to multiply by the reciprocal, which is 4. Okay. So let's see some examples of that. All right, so we're going to solve for h. I'm going to rewrite this. We have a is equal to 1/2 b times h, and I want to solve for h, so there's h. So h is being multiplied by b, and it's also being multiplied by 1/2. So first thing I see is the b, so I'm going to do the inverse of multiply by b, which is divide by b. Those cancel. We have 1/2 h is equal to a over b. We can't simplify a over b, it just stays a over b. And to get rid of this 1/2, we can multiply by the reciprocal of 1/2, which is 2. So let's multiply both sides by 2. Those cancel because 1/2 times 2 is just 1. H is equal to 2a over b. Because this is like a 2 over 1, so 2 times a, 1 times b is 2a over b. And that is H. All right. How about V equals 1/3 capital B times H? And we're solving for capital B. All right. Looking at capital B, I see it's being multiplied by H, and it's being multiplied by 1/3. So let's do the opposite of multiply by H. Let's divide both sides by H. So you have V over H, because that cannot simplify, is equal to 1/3 B. How do I get rid of that 1/3? Multiply by the reciprocal 3. Because 1/3 times 3 is just 1, so that's why it cancels. And we're left with 3V over H. Because remember, this is 3 over 1. 3 times V is 3V. 1 times H is H. All right, so we have K is equal to mv squared over 2, and we're solving for m. Okay, so a couple things are happening here. M is being multiplied by v squared, and it also has a big grouping symbol that's dividing it by 2. So when I see this grouping symbol right here, that's what we need to get rid of first. So opposite of divide by 2 will be times 2. Okay, so those cancel. You have mv squared is equal to 2k. And we're solving for m, so we're going to do the opposite of divide by v, or multiply by v squared, which is divide by v squared. And then 2k divided by v squared does not simplify at all, so it just stays like that. So the answers that we're getting, we're not getting simple constant answers. We're not getting a number for an answer. We're getting another expression, and that's the whole thing for literal equations. All right, solve for t. So you have A is equal to P plus P RT. There's T. All right, a couple things are happening to T. It's being multiplied by P and R, and we're adding P. Do inverse operations. So we're going to start with add P, do the opposite of that. So let's subtract P, subtract P. So I have A minus P. And it's important, see how this is an uppercase P? Be careful that you write uppercase P, because sometimes you might have a lowercase letter along with that in your equation, and they're not the same thing. So be careful about that. Those cancel. P, R, T. We're solving for T, so we're going to do divide by PR, divide by PR. T is equal to A minus P over PR. And see what I did right there? I accidentally wrote an uppercase R. I can't do that. If I start with a lowercase r, that is not the same variable as an uppercase R. You have to make sure you are writing the same variable. All right, let's try one more. Let's try a crazy looking one. Here we go. A equals 1/2 H times B1 plus B2, and we're solving for B1. Okay, don't freak out about this equation. I know there's a lot happening, but when you have something in parentheses like this, let's start on the outside of that, okay? So we have 1/2 and H. It's being multiplied by, so let's address that. I'm going to divide both sides by H, because I want to get rid of this. So I have A over H is equal to 1/2 B1 plus B2. All right, next thing I'm going to address is this times 1/2. Let's multiply that by the reciprocal to get rid of that. Times 2. Cancel. Now we have 2A over H is equal to B1 plus B2. And now we're out of the parentheses because there's nothing that's being multiplied by. Subtract B2, subtract B2, and we're left with 2A over H minus B2 is equal to B.